Hello, in this video, we're going to be looking at the first half of lesson 9.1, which is on calculating the areas of triangles and quadrilaterals. The essential questions that we'll be covering in this section are how do you calculate the areas of triangles and special quadrilaterals, and how do you apply the formulas and properties to solve problems involving triangles and special quadrilaterals. Let's start off with the area of a rectangle. You're likely familiar with this formula. The area of a rectangle is found by calculating the base times the height. So that lowercase b is the base and the uppercase h is the height. For a parallelogram, the formula is actually the exact same. Area equals base times height. But it's important to recognize that for a parallelogram, the height is going to be the perpendicular distance from the base to the opposite side. So the base and the height together are going to form a 90-degree angle. So sometimes the height might be drawn inside the parallelogram like it is in that first picture, whereas other times it might be outside. So for example, here's the height, because that's the distance between the base on the top and the base on the bottom. So my base would be that value and my height would be that dotted line that is the distance between the two bases. So let's go ahead and calculate the area of some parallelograms. The first thing I'm going to do is just write down my formula, area equals base times height, and then we have to carefully identify the base and the height. There are some extra numbers in this first picture. The base and height have to be perpendicular to each other. So the 7 right here is going to be our base, and the height is going to be 2 because that 2 inches there is the distance between the two bases that I outlined in green. So we're just going to take 7 times 2, and that is equal to 14. So the area of the parallelogram would be 14 square inches. Remember that area is always a unit squared. For my second parallelogram, I have a little bit of a problem here because I am missing the height. But I can calculate the height if I use some properties of parallelograms. Remember that in a parallelogram, the opposite sides are congruent and parallel. So this side over here is going to be 5. And then this side up here is going to be 6. Well, if we focus in on this right triangle right here, we can go ahead and calculate the height by using the Pythagorean theorem. A squared plus b squared equals c squared, and c is the hypotenuse. So I'm just going to go 3 squared plus h squared equals 5 squared, and then we'll solve. Going to subtract the 9 to get h squared equals 16. And then we can take a square root of each side to get h equals 4. So now we have everything we need to calculate the area. Remember, the area is the base times the height, and the base and the height have to be perpendicular. So the height is the 4, and the base is the 6. So area equals base times height is just 6 times 4, and that is 24. Don't forget your unit. This one is also in inches, so our area is inches squared. For this next example, we want to find the perimeter of a rectangle in which the area is 154 square inches and the height is 11 inches. So the first thing I need to do is figure out what the base is. So let's go ahead and use the area formula for a rectangle, which is base times height, and we'll just use it in reverse. So this time we know the area is 154, and we don't know the base, but we know the height. The height is 11 inches. And now if we just divide by 11 on each side, 154 divided by 11 is 14. So now let's kind of visualize a rectangle here. So our base is 14, and the height is 11. And then remember that it's a rectangle, which is a parallelogram, so the opposite sides are congruent. So now if we want to calculate the perimeter of the rectangle, the perimeter is just the distance around the rectangle. So I'm going to do 2 times 11 because there are two sides that are 11, plus, and then we'll do 2 times 14 because there are two sides that are 14. And now if we just add those up, that's 22 plus 28. So our perimeter is 50. And then we'll put the unit back in, it's 50 inches. Here's a quick try now for you to try on your own. Please pause your video and give that one a try. All right, here is your solution. We use the area formula. So 50.4 equals 12 times h, divide by 12, and we get 4.2. Now let's move on to triangles and trapezoids. The formula for the area of a triangle is half that of the area of a rectangle or a parallelogram. So the area is equal to 1/2 base times height, or another way that you can write the formula is base times height divided by 2. Once again, we have to remember that the base and the height must be perpendicular. So in this first picture here, I have my base and I have my height, and notice they form a 90-degree angle. In the second picture here, we have the base here and the height would be there. That way they form that 90-degree angle. Then the area formula for a trapezoid is area equals 1/2 times the sum of the bases, so B1 plus B2 times h, or you can also write it as area equals B1 plus B2 times h all over 2. And once again, the base and the height have to be perpendicular. So the height is going to be the perpendicular distance between the bases. And the bases are those sides that are parallel. Let's just add that really quick here to our notes, that B1 and B2 are the bases, and then the height, again, is that perpendicular distance between the bases. So now let's go ahead and find some measures in triangles and trapezoids. For this first problem, we want to find the area of a trapezoid in which base 1 is equal to 9 centimeters, base 2 is 12 centimeters, and the height is 3. The first thing we can do is just write down our formula. Area equals 1/2 B1 plus B2 times height. And then let's substitute in the values. So 1/2 B1 is 9 plus B2 is 12. And then the height is 3. So that means we need to take 1/2 times 21 times 3. And I'm going to just do these two first. 21 times 3 is 63. So I have 1/2 times 63, and that is equal to 31.5. So the area of our trapezoid would be 31.5 centimeters squared. In part B, we want to find the height of the triangle below that has an area of 192 centimeters squared. Okay, let's go ahead and start by writing down the formula for the triangle's area. Area is 1/2 base times height. Now this time we know the base is 24. So area is 1/2 of 24. We don't know the height, but we do know that the area there is 192 centimeters squared. Then I'm just going to take half of 24, which is 12. So 192 is equal to 12H. Now just divide each side by 12. And that is 16. So the height of our triangle is 16 centimeters. In part C here, we want to find the value of B2 of the trapezoid, which has an area of 231 millimeters squared. So that's our area. And then we have the base 1, and we have the height. We're missing B2. So let's go ahead and start by writing down our formula for the area of a trapezoid. 1/2 times B1 plus B2 times height. And then we can sub in the values that we know. The area is 231. 1/2, and then we have B1 is 23 plus B2. And then our height is 11. And then as far as simplifying this goes, you could probably do it a lot of different ways. But what I'm going to do is I'm going to take 1/2 times 11, which is 5.5. And then if we have 231 equals 5.5 times B1 plus B2, which I guess I know B1 is 23 plus B2. Now we can simplify this kind of nicely here if we just divide each side by 5.5. That gives us 42 equals 23 plus B2. And now if we just subtract 23 on each side, we'll get our answer of B2 equals 19. And that's just, again, subtracting 23 from each side. So the base 2 is 19 millimeters. For the try now, you're going to find the area of the triangle below. But before you can find the area, you need to find the base. We have the height here is 12 meters. We need the base. And because it's a right triangle, you should be able to find that base using a theorem that we use very frequently in this course. Go ahead and give this a try. Please pause your video, and then when you hit play, I'll have the solution posted. All right, here is your solution. The first thing I did was the Pythagorean theorem, and using a squared plus b squared equals c squared, we get the base is 16. Then you have your base and your height, and since it's a triangle, we can use the formula area equals 1/2 base times height. So take half times 16 times 12, and you'll arrive at 96 meters squared. This concludes lesson 9.1, day 1. In the 9.1, day 2 video, we'll look at how to find the areas of rhombuses and kites. Thanks for watching. Bye.